Hello guys, and welcome back to this masterclass for the beginners in C programming language. It's your guy once again, the Wolf, and today I'm so excited to make this video for you, specifically for you, a new beginner, to make sure that, hey, I want you to be the best programmer around everybody. So welcome once again. Let's get started. Welcome apprentices. So we're going to start from here, from what you're seeing on the screen. And if this is your first video today, this is the video that you landed for today, I'm using code block to program in C. So guys, let's do it. So in the previous class we talked about we're still talking about data types, and we have been talking about data types, characters, number, decimal precision. We talked about memory size, and also we did real life examples. So today we want to talk about type conversions, and we will talk about constants, which is a different thing to do with data, but for now let's do the conversion. So I'm just going to let's say a little thing about this. So sometimes you have to convert the value of one data type to another type. This is known as type conversion. For example, if you try to divide two integers, let's say 5 by 2, you will expect the result to be 2.5. But since we are working with integers and not a floating point value, the example that I'm going to do here is going to output 2. So let's do it. So I'm just going to declare a variable here, and I just want an int, and I call that int, assign it 5, and a comma there. And then again I create another data here, which is an int type, and then name it, why are you jumping? I name it y is equal to 2, right? And again, let me just space it, because we've been talking about spacing, which has no effect but for readability. And again, I just want to have a sum here, which is an int is equal to sum. No, not really. I create a variable sum, not source but sum, is equal to 5 divided by 2. Let's see what we get. So I'm going to, and I don't know why even I created this variable. Okay, just divide this and print the answer here. So the answer should be in a new line. No, I don't need. Let me just delete this, and then I should put the format here, which is percentage d, or I should do that, then comma and sum, just like that. So let me print this out and see what I have. And so compile this, is running there. So we got 2. And by the way, why did I do this? Anyway, let's just take x here and put some 5y here. Let's see, let's run it. We'll get the same answer, but as of now there's something I want to show you guys. So to get the right result, you see, this is not the right result. 5 divided by 2 is not 2. There is a remainder, you see. So to get the right result, you need to know how type conversion works. So there are two types of conversion in C. We have implicit conversion, which is automatically, and also we have explicit conversion, which is manually. So let's talk about this implicit conversion. So implicit conversion is done automatically by the compiler when you assign a value of one type to another. For example, if you assign an int value to a float type, let's see what we normally get. So let's see. Let me just should I comment this? Let me just comment this for now. I'm just commenting them out. Shift hash shift hash, and yeah, leave that alone. So I just want to create an automatic conversion and int to a float. So I declare a float here, and I call it f, or yeah, float meaning float. So my float should be, I should assign, let's say, a 9 there, right? And then I print out, let me just print this out first. So I'm going to print f here, f. So run this. Oh, what are you saying here? X nini. Let me just remove them. I don't want you to give me any problem. So run it again. Yeah, I got 0. Whew. What? No, it should not be 0. Something is wrong here. Oh, float. My float and this equal to that, and then I printed f. Oh, I didn't just put f here. You see, you should use the correct format there. So let me just run it again. I should get 9.0000. Now let's talk. So as you can see, the compiler automatically converted the int value 9. Let me just run it again, because I'm talking of the thing that you're not seeing. So you see, so the compiler automatically converts the int value 9 to a float value of 9.000. How many zeros are there? 5 zeros. This can be risky, you know, as you might lose control over a specific value in a certain situations. So especially if it was the other way around, the example that I'm going to do here, I'm just going to convert the float value, which is 9.99, to an int value of 9. So having such a kind of result, you might make a very, well, I don't want to talk about that, because yeah, you know. So let's do it. So I'm just going to create again, this is let me just add an int here, int, and then my int, I just want to assign it, and remember just to give us a small space there, and 9.99, yeah, just like that. And then let me just print out these. Can you just convert this? I mean, just you're doing the wrong thing around here, bro. So yes, I need to change this, change that to now f again. Now just delete this, put in your my int there, copy and paste. So this one should give us what, a 9. So because this is this, you see, this now we are talking about automatic conversion, right? No, we have here 9.9 as our integer here. Our value, our variable is my int, and our value is 9.99. So to print out this and this format here, I've placed my int in there. So I just want to format it to an integer. So let's run it and see whether we can get a 9 there. And if we get a 9, just know that that is automatic conversion. So you can see here we have 9. Now this was really good. So what happened to 9.99? Let me repeat it. What happened to 0.09? What happened to 0.99? What happened, bro? How can you explain that? So we might want the data in our program, so be careful, you know. It's important that you know how the compiler works in these situations, so to avoid unexpected result. So another example, if you divide two integer, let's say 5 by 2, you know that the sum is 2.5, And as you know from the beginning of this, the first line I wrote here, if you store the sum as an integer, the result will only display the number 2. So we found out that, right? Therefore, it will be better to store the sum as a float or a double, right? So to do that, you need to, let's say, a float sum of the sum of this. So the sum should be 5 divided by 2, and make sure you close that. And if now I do what, I print this, so you see already we know that this number is going to have some, as we checked in the previous. But now if we print this out as sum, and then this probably should give us a 2.000. How many zeros? Okay, there are 4, 5. Yeah, so if I run it, so it's good. Some problem, probably I did not change this. Is to that, and let's kill the CMD over here so that we can run it again. So let me just run this. Wow, you see, now it's 2.0. So it's good that when you have such a kind of values should be stored in a float type of variable. Yeah, so so why is the result 2.00 or 2.5 zeros there and not 2.5? You see, are we wrong or something, or the computer is wrong or something? Yeah, you know, maybe the computer is wrong. So well, it's because 5 and 2 are still integers in the division, right? So in this case, you need to manually convert the integers value to a floating point value. So let's talk about explicit conversion. We have seen that this manual, this automatic conversion is not really giving us the right answers. So let's do it explicit conversion. So explicit conversion is done manually by placing the type in parentheses in front of the value. So let's consider our problem from the first code that we wrote. We can now get the right result. Let's see how we can do this manually conversion, and that will be into a float. So let me create a float here. Already we have a float and the sum, and now what we do is we concatenate. This is not concatenation. This is just the, what do we call this? I'm remembering the right name for this. So in this, you're going to tell it, no, bro, I need a float. No, just put your float in there. And now if we print out the sum, see what we get. Look at our answer, bro. There we have 2.5000. You see, now because that is it, that is the right answer. Now this is 2.5 with another 5 stories zeros. So you can place the type in front of a variable. So this is the type. You see, this is the type, which is a float. Now you can place it in front of the of a variable. Yeah, right. So let's do another example here. Okay. So this we placed it manually in the parentheses, and we got the right answer. Now let's do by just placing the type in front of a variable and see what we get. So let me just first of all just comment this out, and let me create an int and call the num1, right, and then assign it 5. From here again, let me create another int and num2 will be equal to 2, and from here again create a float. I can bring this here now, copy that or cut it, and just bring it here. And now here I just want to have a float, and again now I bring in my two variable, which is num1 divided by num2 num2. Yeah, so if I print the sum, see what we get. This means that I need to kill this over here, so we just run it again, and there we go, 2.5000000. Yeah, so that was awesome, that was awesomely good. And now since we have learned about decimal precision in the previous lessons, you could make the output even cleaner by removing the extra zeros if you like. Remember, what are we going to do with the zeros anyway? So to do that, to make that cleaner, remember we just do a little change here, because we change here by placing the number of zeros that we want. So we just want only one. So decimal places that we would have there is only one decimal places. So remember also to put dot here. So this dot means we need one decimal place. So let's run it again. Once I run this, I should kill this CMD, and I wish this code block could be even printing down on the console. That would be so awesome. Maybe I haven't checked it. It's there, probably it's there. So let's run this, and there. So we have 2.5. Now that's more cleaner, guys. Yeah, it's true. So let's talk about a really live example where we can use such a kind of things that we have done already. So here, the real life example of a data type and type conversion, where we create a program to calculate a percentage of a user score in relation to the maximum score in a game. So my mic is just keeps on dropping here and there, but I'm gonna catch you right here. So let's do it. So I'm just going to set the maximum possible score in a game to be, let's say, 500, and also let's start anyway. Let me just clean all this. Now we are using what we have learned just in a few seconds ago, and do it in a real life example. So let me just comment here and say that now I'm setting the maximum possible score in the game to 500. And remember, guys, C. So once you learn C, you can develop games. Remember, I think most of the games, the most complicated games I can say, they're made with they're coded with C, in other words. So just drop down here, int maximum. Actually, once upon a time I did develop a game using C. It was really good. Score, and I just put maximum 500, and then I want the actual I need the actual score of the user. So actual score of the user, and now I should send it an int there, int user score, right? And I assign it 424. 4.4 is okay. And then now let me calculate the percentage of the user score in relation to the maximum available score. How do you do this? Okay, you see, first of all, let's convert the user score to a float to make sure that the division is accurate. So let me just do it over here. So I'm just going to create a float and then a percentage equal to, remember what we just said, and now here we are converting to a float. And now I just want the user score here, which is 400. Make it percent first of all. So I'll paste it here and just do what? Divide by the maximum. This actually is maximum. Just this over here. So it's just 404 out of 500. And I created a float. And then now you multiply by 1,000, right? I mean 100. Where is the 1,000? Where do you get 1,000 from? So let's print the percentage. So here we have the percentage, and let's print the percentage down here. Actual. So this was the actual. What is the problem? Let's cut this, and the actual should be here. And now here actually I should have said something. We are calculating the percentage of the user. Useful, but I'm just trying to explain if you ever get lost. So here again I was just I should write something here. You should even cut this down and you should say, let me add another comment here. So I'm just, again, we must convert the user. So convert user score to float to make sure that the division is accurate. So that is it. And that's what I did over there. So I'm just let me print here. So I'm just going again to comment here and say that print the percentage, just like that. So I should print my main method, the printing method or function, and say print function. What do you want to print, bro? I just want to print the user. So double quote there and say users. Just need to put that over here. Users percentage is, put this percentage and convert to 0.2 so that we can 2 decimal places and put a comma there. And now let's print the percentage here. So this is the real life example. So put a comma there and put the percentage over here. Just space there so you can get the space. Now let me just run this and see whether we have the correct answer. It means I didn't put this over here. Let me run it again. There you go. So the user percentage is 86.88.80. So the result is as we expected. So guys, let's talk about, now we are done with the data types in what? In C. So let's talk about constants. So what are constants? So constants, for example, if you don't want others or yourself to change the existing values, you can use the constant keyword. So this is something that when you want something not to change, for example, let's say you have the formula for calculating the circle, the area of a circle is pi d or pi squared, you see. So that pi d or whatever the pi formula normally does not change, so that's purely a constant. So you should declare such a kind of a variable or a value as a constant. So this is something that you don't want to change in the future or whatever. So we will declare the variable as constant, which means that it's unchangeable or it is redundant. So to do that, let me just delete all this, or should I, let me just add another one here. Should I add another file? No, I don't want to, I just wanted to add a file. Add file, and okay, because they won't have the main, let me just remove all these, and I'm clean here. So let me create a constant here. Constant, this is right here. So a constant int, and I call it my num, and I assign it 9. And it seems that I forget this spacing. You know, when you talk and doing at the same time, some things will drop. So this is my num will always be 9, no matter if you try to change. So let's have another one here, and the same variable, right? This one, the same variable, right? It's called variable because it's changed, but now I've declared as constant. And again, I just want to assign, let's say 10. You see, this will give us a problem. I'm very sure. Let me just print out. So print function, and remember to the format. So this guys will give us a problem just like that, but let's do it so that we can confirm whether we are wrong or we are just Java stories, you see. So I'm just going to put a comma here, and I write my num here. So you see, the first time we assigned it 9, and then we come down over here, and then again we signed. But the first one we declared as constant. The second one we never did that. So let's print out and see. So there, and where is my return function? From here. Oh, my return function is not there. Okay, you do that. So my return function should be here. Return 0. just like that. So let me just run this. It's saying, so though we cannot see the problem where it is, but it's not going to run because it's saying there's a problem here. I wish it was like another IDE where it can give you exact problem, and now it's because we have a problem here. But if this is, let's say, something like that, and you can see the compiler itself has reviewed terribly and saying that there is an error. So it could have said something like assignment of read-on variable. So you should have said something like that. So you should always declare a variable as a constant when you have value that are unlikely to change. For example, let's say let's delete this. You can leave this, and let's have a constant there, and there is an int and call it minute. Is a minutes hour. So how many minutes are there in an hour? It's just 60 minutes. So if I print this, let's say print this, so I just want to print in a new line, so it's a backslash n and minute by hour. So copy this and paste here. So yeah, for example, minute per hour will never change. So if you have a variable in your application and you don't want to change a variable that is you will never change, simple as that, just use this constant. So let's run this again. So is saying something not clear here, so let me check it. So I have where's my problem here? Const int there. I'm okay. Then print this. The print, I think I have a problem here. Oh, okay. Let me just find out where is here. So I have not included these. Control Z. The problem is just here, just like that, and then let me run it. Yeah, there we go. 60 seconds. So that is all about declaring a constant. So notice on constants, when you declare a constant variable, it must be assigned with a value. So you can never just leave it like this. But I think you can do this. No, it won't work. It won't work. It must be assigned, just like we have done over here. It's equal to 60. So if we say that, let's see whether this can work. I just want to do it. Anyway, let me do it. Just prove it out. We are here to prove it out things. So I come here, like this, copy again. Now let's again assign it. Let's see whether it can work. If it works, I think it's strange. It will be strange because that's what the document says. So this should bring an error. So let's see whether it can give us an error. So run it. Yeah, yes, there's an error. So you can't just assign, you must assign it once you declare it. So let's talk about a good practice. So another thing about constant variables is that it is considered good practice to declare them with uppercase. So for example, the formula for pi is straight pi, right? So it is not required but useful for code readability and common for C programmers. So to do that, for example, I was born, why am I even printing? Okay, constant, and int, and so which is my birthday, for example, my birthday, right? My birthday. Oh, well, how is the birthday being written in capital? But there I cannot write good spelling with capital. What's wrong with me? So let me just guess. The birthday is written like this, but birthday here. So birthday here I can assign it 1994. Yeah, just like that. So this one is really good to declare a constant, something that does not change with a capital letter, just like that. So if I run it, I will just get the result. So once again, we are done with constants. So let's talk about variables. You see, operators. I mean, so let me see how long is the lesson so far, because I normally want to make up for 5 to 50 seconds. Okay, let me see what I can do with these remaining minutes. So let's talk about operators. So operators are used to perform operations on variables and values. So let me do by example. So we're going to use a plus operator to add together two values. So how can we do that? So I'm just going to declare, let me just remove, maybe I should, let me just remove this, and I declare an int, and I call it num, just like that, and I say it's actually 50 plus 100. The plus there is an operator, so if I print out the sum of that, so print, and I just write what should I do there, giving the format type. So here I'm just going to percentage. Now this is a float number, now it's a decimal number, so I can put an I there, and I can put a comma here. An I actually means integer, you can put a D there, so I'm just going to print this now here. Now, so let me just print out and see what I have done that. So it's 150. The plus is just an operator that we use to add two numbers. Although the plus operator is often used to add together two values, like in the example that we have done here, it can also be used to add together a variable and a value, or a variable and another variable. So let's do it. No, we're not tired. So let's first of all, let's add that, and also let's have another int here, and because it's 2 is equal to, let's now pick someone. Actually it should be someone. So it should be someone plus, now we are adding a variable to a value, a variable with a value. So a value here is going to need 200, right? And again, let me create another one here. Control Z broad, and my back is really, I don't know what I want. So int, and sum 3. And guys, I'm really happy because my tutorials they have some views, and also the number of subscribers are increasing, and I feel like, hey man, I'm growing, and this really motivates me. I don't know what to say, but thank you so much for that. So let's add some 2 plus now some 2 again. Whew. I can add some 2 and let's do it. Some 2 and some 2. Now this is a variable and with another variable. So we have added a variable with an integer, a value with a value, a variable with a value. Now it's a variable plus variable. It's really complex. So if we run this out, remember we can always have our answers. So let me just have 3 printing functions here so that we can check out and see whether we got it right. So the first one here is sum1. The second one is sum2, and the third one here is sum3. I mean sum3 there. So let's see in a new line, of course, backslash n backslash, and the last one we don't need a new line because save that. Just combine and run. I don't know why. Oh, I did not put this. Normally I do this, I don't know why. So just run this again. So you can see we have 150, 350, 700. So you can see you can do that. A value to a value, a value to a variable, a variable to a variable. Yeah, so C divides the operators into the following groups. So we have some operators, and the C has divided them in some group. I think there are 5 groups. So the first operator is arithmetic operators, which is mostly used to arithmetics calculations. The second one is assignment operator, which we assign things to another thing. And also we have comparison operators. Comparison operators is just we compare 2 things. And the logic operators, where we check whether logics, that's the way with logic. And also we have the bitwise operators, but we will start by talking about arithmetic operators. I don't know how long it is, and I think we should do what? We will talk that in the next lesson as we talk about what operators, various operators in C. So we will talk the one that I've mentioned, and we will start off with arithmetic operators. So see you in the next lesson. Don't forget to subscribe, don't forget to invite your friend, and please kindly, if you like what I'm doing or this is useful, please make sure you subscribe and hit that button over there. You make me happy every single moment I see new views and base views. You motivate me a lot more time, bro, sis. Thank you so much, and goodbye. This is your guy, the Wolf. Goodbye.